angles between 90 and 180 degrees. The three trigonometric ratios were originally defined in terms of right triangles because that was useful in solving real-world problems that involved the right triangles. The set of input values of these ratios is the set of angles between 0 and 90 degrees. But now we will extend the definitions for angles between 90 and 180 degrees. So we can extend trigonometry beyond the right triangles and use it to solve problems involving any triangles. Let's start. The x and y axes divide the coordinate plane into four quarters called quadrants. The four quadrants are labeled 1, 2, 3, and 4. First quadrant, second quadrant, third quadrant, fourth quadrant. Now we begin by drawing a unit circle, a circle centered at the origin with radius 1, as shown in figure. We will place a right triangle on the xy plane. The hypotenuse will be the radius, with the adjacent side on the x-axis, the opposite side parallel to the y-axis, and the angle theta at the origin. We can label the intersection of the hypotenuse and the unit circle as by its coordinates x and y. Look at the angle theta, and we will find the sine of theta. The sine of theta is y over radius. But the radius is 1. So sine of theta is simply y coordinate. We will do the same with the cosine of theta. Cosine of theta is x over radius. Cosine of theta is simply x coordinate. The y coordinate is the sine of angle theta. The x coordinate is the cosine of angle theta. Any point can move around the circumference of the circle as the point moves counterclockwise around the circle from 0 degrees. The angle theta changes, and the values of sine of theta and cosine of theta also change. Let x and y be the endpoint on the unit circle of an angle theta. The x and y coordinates of this point can be described as functions of the angle theta, and we can change x by cosine and y by sine. Take a look. At the moment, we are not interested in the unit circle as a whole. We are only interested in the half circle for angles between 0 and 180 degrees. For the cosine axis, numbers to the right of the 0 are positive. Numbers to the left of 0 are negative. For the sine axis, numbers above 0 are positive. I hope you understand why the cosine between 90 and 180 degrees is negative. Let's see how it works. Use the unit circle above to find sine and cosine of 30 degrees. From 0 degrees, counterclockwise, get 30 degrees. From this point, take the sine of 30 degrees and cosine of 30 degrees, as we do to get the x and y coordinates of a point in the Cartesian plane. Pay attention. You should check the results on your calculator. Find sine and cosine of 120 degrees. From 0 degrees, counterclockwise, get 120 degrees. From this point, take the sine of 120 degrees and cosine of 120 degrees, as we do to get the x and y coordinate as a point in the Cartesian plane. Pay attention. You should check the results on your calculator. The next example you should try to solve by yourself and then check the full resolution. If you enjoyed the content of this video, don't forget to subscribe. And if you have any questions, feel free to ask or suggest anything. I will be grateful.